I guess we are good to start. So, so thanks everyone. Thanks for joining us this morning. I hope everyone enjoyed Cisco Live so far. This is our last day, and I'm Awais Khan, Cybersecurity Solutions Engineer at Cisco. So today we are going to talk about our unified SASE platform powered by Cisco Secure Connect. And this is the brief agenda we would like to cover in next 30 minutes. So we'll have a very quick introduction on SASE and Cisco Secure Connect. We will then dive slightly deeper into the architecture, into its use cases. We will then explore how we can connect different type of devices, locations, and users to our SASE platform. I also have two demos available. We will see if we get enough time. Maybe I will showcase that. Otherwise, we can always have that after the session ends. So with that, let's get started with quick intro to SASE. A quick poll. How many of you are familiar with the concept of SASE in general? Okay, which is good. So for those who don't know, so SASE is basically a term coined by Gartner a few years back. So it's an architecture that can help to address some of the challenges which we are facing these days around securing hybrid workforce and providing connectivity to highly distributed applications, right? So it's an architecture, basically convergence of two major technologies, networking and security, delivered and managed by cloud as a service. So on the networking side, we got SD-WAN, while on the security side, we got SSE or Secure Service Edge, another term. So SSE is all about providing always on cloud edge security features. So Cisco Secure Connect is our unified SASE platform that powers everywhere connectivity. It also provides always on cloud edge security features, and overall it improves remote work experience. So idea here is that wherever you work, your complete traffic will be proxied through our SASE architecture before it reaches to the final destination, which could be over internet, which could be a SaaS-based application. It could be your private application hosted inside your public or private cloud infrastructure, or it could be hosted in third-party co-location facilities. So it is built on the Meraki platform, which means if you are already using Meraki infrastructure, you can now use the same dashboard to manage your cloud edge security features. If you already got Meraki MX inside your organization, those MX appliances can connect to this fabric automatically in a matter of some clicks only. In fact, we also have very strong integration with our Catalyst SD-WAN appliances. So if you are using Catalyst SD-WAN, maybe on some locations, that can be also integrated with this fabric. We can also automate the creation of tunnels here. We also support non-Cisco equipment as well. So in some locations, you got different vendor firewall. That's okay. It can be also integrated with this fabric as long as they support standard IPsec parameters. A high-level overview on the architecture. So on the left-hand side, we have different type of users and devices. So on the top, we have branch office, right? Branch office can have SD-WAN edge appliance, which could be Meraki MX, it could be Catalyst SD-WAN, or it could be third-party device. We then got manage endpoint, your corporate users who are working from everywhere. Then we got unmanaged endpoint, maybe your contractors or BYOT devices, right? That want to access your applications from outside. In the middle, we got our Secure Connect fabric with these different security layers. So these layers basically used to secure your access to the internet and also help you to connect to your applications in a secure and controlled way. On the right hand side, you can see different applications and services. You can have any service running on internet, maybe SaaS based application, public and private cloud infrastructure, your DC locations or third party co-location facilities. So all different type of users and location can connect to this fabric to achieve these three outcomes. On the top right corner, secure internet access, secure private access, and site interconnect. So let's have a quick overview on these three use cases before we jump into the technical architecture. So secure internet access. So objective here is that wherever you work, your complete internet traffic will be proxied through our fabric before it reaches to the final services on the internet. So basically, we want to make sure that you always access clean and allowed content over internet. So these are the different security layers where your internet traffic will be evaluated in line between your session. So everything starts with DNS layer security. So once you turn on Secure Connect, we will be also acting like a recursive DNS server for your internet traffic. So whenever you try to open any website, we will first receive DNS requests from you. At DNS level, we can filter down majority of unwanted or bad traffic, right? Once we find the website you're opening, it's a clean website, not malicious, and allowed by corporate policy, then the complete traffic will be proxied through our fabric. Once we receive the complete traffic, it will first evaluated by our cloud firewall, where you can have layer 3, layer 4, and layer 7 security rules with IPS enabled. After that, let's say nothing get blocked, traffic is clean and allowed, then it can be further evaluated by our web security gateway, a kind of web proxy that can enforce advanced security features, things like TLS decryption. So once we perform TLS decryption, we now have more visibility and control. So majority of today's internet traffic is encrypted anyhow, right? So once you decrypt the traffic, you can control what type of content you can download from internet. We want to also make sure the content you are accessing on the websites is clean, not malicious. We can also enforce some granular controls around the usage of different SaaS-based applications. For example, maybe you want to allow webmails or box.com or dropbox.com, but want to block the uploading capability. Or maybe you want to allow everything. Maybe users can upload data to Box or webmail, but we want to make sure that they are not leaking any sensitive data, maybe credit card details or banking information. So we can also enforce those type of compliance checks as well in a real time. That's internet security. Secure private access. Again, objective here is to securely connect your remote users, your branch offices to your private applications that can reside everywhere. So for remote users, there can be two type of users, right? There will be managed endpoints and unmanaged endpoints. Managed endpoints will have our Cisco Secure Client installed. So a quick poll here. How many of you are familiar with Cisco Secure Client? Raise your hand. Okay. How about Cisco AnyConnect Client? Okay, so it's basically same, right? Last year, we have rebranded our AnyConnect client to Cisco Secure Client. So with the help of Cisco Secure Client, we can connect to our infrastructure for remote access as well. So, so once you connect, you can now access your private applications. And at the same time, the same client can be used for internet security. So we use different connection method. You can have full tunnel VPN to our fabric. So this fabric basically can be act like a VPN concentrator on the cloud. Then with the help of this client, you can establish a full tunnel to this fabric. Once after that, we will be receiving complete traffic from remote users. And after that, traffic can steer towards either private application or it can go towards internet. We also support different methods of connectivity, and I will explain other methods like zero trust access. What's the difference between VPN versus ETA? I will briefly touch on that later. Then we can also help your branch locations to connect to your private applications with the help of a feature called Site Interconnect. So Site Interconnect. So basically, objective here is to simplify your SD-WAN deployment, right? So let's say you have multiple hubs and multiple spokes. So right now they might be having direct connectivity with each other, right? So with the help of this architecture, all your spoke location, all your hub location can be connected to this fabric, and this fabric can be used to centrally manage your deployment. It can be used to centrally enforce all the security policies. So it will simplify your operations and simplify your management. So another good use case here is that maybe you have branch location in Singapore and data center in Melbourne. So instead of having connectivity between Singapore and your branch location, also data center directly over SD-WAN tunnel, they can connect to our Secure Connect data center in Singapore. From there, traffic can be backhauled to from our high-speed fabric, and then it will exit out from Melbourne data center. So it can be used in that manner as well. Basically, it will improve overall experience as well. So now let's explore different connectivity options for branch and hub. So we are going to start with the branch office. So on the left hand side, you can see a branch location, right? That will have our Meraki MX appliance. It can have any other appliance, but you will get maximum advantage if you got Meraki MX, right? Meraki MX will have auto VPN tunnel to our cloud native headend. And then from there, once it's connected, branch will send complete traffic to this fabric. So once we receive the traffic will first evaluated by our cloud deliver firewall. Sorry for acronym, CDFW. It stands for cloud deliver firewall. Once we receive the traffic, it will be evaluated against layer 3, layer 4, layer 7 security rules with IPS enabled. And from there could be two possibilities. If the traffic is intended for internet, the traffic will be traversing our advanced security layers like secure web gateway, CASP that allows prevention before it reaches to the internet. And before it's reached to the internet, traffic will be netted with our public IP address. If traffic is intended for a private application, then it will go to site interconnect, and from there it will be reaching your private applications. Here in this area, there will be also secure tunnels between your Meraki or Catalyst appliances towards our fabric. A very high level overview on the architecture. On the left hand side, you have branch offices which are connected to this fabric. If you got Meraki, it will be auto VPN tunnels with BGP enabled. So with the help of BGP, we can exchange the routing information. So BGP will learn all your spoke site, all your hub sites, and it will maintain the routing table, which can be exchanged with your branch locations. On the right hand side, you can see we have another branch. So that branch is connected to different region completely. This is maybe Singapore. That one is in Australia, maybe in Melbourne. And with the help of interconnect, all the locations will be centrally connected with the help of our backend fabric. From there, we also have remote access connector that will be receiving all the traffic from remote users, and then different cloud security services, right, which we briefly touched in the previous slide. So let's say you got branch office with Meraki MX appliance. Once you turn on Secure Connect fabric, with the help of simple clicks only, there will be two tunnels initiated from your Meraki MX branch office towards our fabric. So again, it depends on which region you pick. Let's say you want to connect a site in Sydney or Melbourne to Secure Connect data center in Australia. There will be two tunnels initiated. One will be towards Melbourne. Second one will be towards Sydney data center. So once we establish the connectivity, we will allocate 500 meg or 500 Mbps of bandwidth for that branch location. And that's aggregated maximum bandwidth. Doesn't matter whether you got two uplinks or one uplink. If you require more than 500 meg, maybe on certain locations like in data center or large campuses, we have some other options available. So I will explain one of the few options in few slides later. But another interesting option would be maybe using VPN exclusion. So maybe for bandwidth hungry applications, you can define a VPN bypass list or application bypass. So those trusted application can then maybe go towards internet directly without traversing Secure Connect fabric. If you got multiple internet links, we can also make sure that we always use the best performing uplink when you access different services over internet. Since we got two tunnels, right? So you are automatically getting high availability. If for some reason Melbourne data center, let's say, went down for some upgrades, you still have backup from Sydney. If both went down, these complete region will be backed up by another region, maybe Singapore or Japan. And for some reasons you decided to use VPN exclusion for trusted internet access, that traffic can still be evaluated by the network security features offered by Meraki MX, things like layer 3, layer 4, layer 7 firewalls with IPS enable, advanced malware protection enable. So Meraki MX got decent security features already that can be used for securing the traffic within the branch or maybe also for direct internet access. And we can also observe the overall end user experience when they try to access the application. That's possible with the help of our built-in Thousand Eyes integration. So inside Meraki dashboard, you will see a tab called Meraki Insights that has thousand eyes capability, basically, that can be used to monitor your overall experience, application experience, which could be your private application or which could be your internet SaaS based application. So what's happening behind the scenes? So this is the screenshot I have captured from Meraki dashboard. So here you can see different type of locations, hub and spoke. So let's say I want to connect a spoke location to this fabric. I click on the assign to Secure Connect region. It will show me all the available regions. For this region, I can use easily Australia one. So once I do that, basically two tunnels will be initiated, one towards Melbourne and second towards Sydney. After that, what will happen? You will notice that inside your site-to-site VPN page, Secure Connect Melbourne and Sydney hub location will be appeared, and that will happen automatically. And then we will advertise a default route from Melbourne and Sydney data centers towards your branch location over BGP. So IBGP will be used here, and then in return, the branch location will advertise its private subnets over IBGP as well. So bidirectional routing exchange will happen. After that, you will notice that two default routes will appear inside your routing table. So that was for the branch, right? What about hub? For sure, you will have multiple hubs in your infrastructure. The behavior of hub will be slightly different than spoke site. And reason is that we want to avoid service disruption, right? Because if it's a hub site, most likely it will be advertising some application over internet maybe, or there could be some other application broadcasted to private network. So default behavior is that when you connect any hub site to Secure Connect region, we are not going to advertise our default route. So that option is disabled by default. So you can still advertise your private routes towards towards Secure Connect Fabric, but by default, Secure Connect is not going to broadcast the default route via IBGP. But that default behavior can be changed if you want for different use cases. Idea is that we want to keep it manual to avoid any service disruption. So, and this is example where we want to turn on that feature. So use case here is that if you want to protect maybe a hub location for internet security, hub location then can use Secure Connect Fabric for internet security. And to make it work, basically Secure Connect Fabric need to advertise our default route. So to make that happen, when you are connecting a hub location to Secure Connect Fabric, there will be an option appear called default route under remote routes. So by default, it's disabled, but you can change this behavior. Once you change that behavior, what will happen? Default route will be advertised by Secure Connect Fabric, and then hub will also advertise this private subnet. So we offer flexible design options. So there will be situations where you may want to use this fabric just for internet security for your branch locations, and you still want to maintain direct SD-WAN tunnels between your hub and branch or hub and spoke. So that is very possible. So in that case, you can play around with the priorities here. So you can keep maybe hub location as a priority one and Secure Connect Fabric as a priority two. So after that, there will be a direct communication between spoke and hub for private application access. And maybe remote user can still connect to Secure Connect Fabric to access the application that is hosted here. So that is very much possible. I would say a very common option. So people still use sometime. I would say most of the time. So from traffic flow perspective, what will happen when you try to open google.com, traffic will go towards internet directly. Not directly after it get inspect via Secure Connect Fabric, but spoke to hub sites will be always direct. Further, some design consideration. So if you have multiple spokes, right, and you want to enable the spoke to spoke communication, so you cannot have one spoke connected to hub directly and another spoke connected to Secure Connect. In that case, spoke A and spoke B cannot communicate with each other. So let's say maybe you have hub and spoke topology where some spoke locations are not connected to Secure Connect Fabric, rather they are connected to only hub location. And you have another spoke which is connected to Secure Connect Fabric. In that case, the traffic will not work between spoke A and spoke B. So just a small design consideration. It's very well documented at our website. What we want ideally, either you want to have keep all the hub and spoke connectivity directly or through Secure Connect Fabric. You cannot have mix of both for spoke traffic. So in that case, Spoke B will also have a tunnel towards Secure Connect Fabric. Once it happens, the private traffic between Spoke A and Spoke B can be traversing directly. Just to reconfirm, you guys can hear me well, right? Does it make sense so far? Okay. So let me quickly forward. So remember I told you if you hit a limitation of 500 meg, maybe you got some large sites which got maybe more than 1 gig of bandwidth for internet. What you can also do here on those locations is that you can also bring Catalyst SD-WAN. Then Catalyst SD-WAN can create tunnels towards our fabric, and those tunnel creation can be automated as well. And then you can create multiple tunnels. So you can have 4 to 8 tunnels, and then you can turn on ECMP or equal cost multipath. How many of you are familiar with ECMP as a concept? Okay. So I can see majority of hands raised. So idea here is that in any Cisco router and even in SD-WAN, Catis SD-WAN, you can create multiple tunnels towards same location, maybe towards data center, and you can turn on load balancing across multiple links. So while doing that, you can achieve higher bandwidth. So for larger sites, you can still put Catis SD-WAN. Those Catis SD-WAN can be integrated automatically. You can have multiple tunnels to achieve higher bandwidth. So this is the traffic flow for a scenario where you have data center with Catalyst 8K router, and that data center is hosting some applications. On the branch, you have Meraki MX. Meraki MX will have auto VPN tunnels towards our Secure Connect Fabric. From there, traffic will go through Cloud Deliver Firewall, and then it reaches all the way to branch offices. So traffic flow remain the same, doesn't matter which type of device you use. Pretty much same for internet security. Let's say if you have Catalyst SD-WAN on some branch locations, then the traffic flow will remain the same. You can protect your branch offices via Secure Connect Fabric while leveraging all the security features which we have to offer under this architecture. Securing remote users. So there would be two possibilities here, right? Two type of users. You may have managed endpoint and unmanaged endpoint. So for managed endpoint, what you can do, you can turn on full tunnel VPN to our fabric. Once you turn on that, we will be receiving complete traffic from your remote endpoint towards our fabric. Once we receive the complete traffic, we can then, traffic will first evaluated by Cloud Firewall. And from there, again, two possibilities. It can go to your internet application or it can go to your private application. So let's say for some reasons, you don't want to have full tunnel VPN. What you can also do, we have one module called Zero Trust Application Access or Zero Trust Access. So it's not VPN. You don't have to manually connect it. You have to just enroll your client with the fabric. Once you enroll that client, this will automatically connect it to this fabric. What will happen every time you try to access the application, we will authenticate and authorize you and make sure you have right security settings before you access the application. And that's the major difference between VPN based technologies versus zero trust access. With VPN based technologies, we perform authentication once, authorization once, after that you will have full or limited access to the network. So VPN is like VPN basically offer network level access, while zero trust application access offer you per application access. So whenever you try to access any application on a per session basis, we are going to authorize you and making sure you have right security setting, and there will be multiple tunnels. Each application access will have a unique individual tunnel. So I would say it's more modern and secure method, but there are some strong reasons to have both options available. There are some use cases where you may still require full VPN connectivity for certain type of scenarios. So we have both options, but this is one of the common option people use. So that previous model mainly responsible for remote access, right? So how about internet security? So we can do that with the help of one model called umbrella roaming model or roaming model. So which can be enabled inside secure client itself. So once you enable that, your complete DNS traffic plus web traffic will be proxied through this fabric, evaluated by these different security layers before it reaches to the internet. The traffic flow will remain the same. For contractors who want to access your private hosted application, they can connect by using this fabric. So what will happen when we publish any your private application? We will assign a public URL that will be resolving to our fabric. So your contractor will open that public URL. We will receive the traffic. We will authenticate. We will authorize. We will make sure the traffic is coming from right location or intended location. And after that, traffic will go towards final application. So we got just 5 minutes left, so I cannot present both of the demos. So I'll show you a quick teaser on the dashboard. Then we will have a brief demo on the end user experience. So this is Meraki dashboard. So on the top, you can see a tab will appear called Secure Connect. That will be used to manage your complete internet security, plus all the cloud edge security features like remote access, VPN, zero trust access will be available to consume directly from this dashboard. Again, one dashboard to manage your complete networking stack plus all the cloud edge security features. So I will skip this part. So right now I have logged into my remote worker who is having this Cisco Secure Connect installed. So I'm not using VPN here. I'm using Zero Trust Access module and Umbrella Roaming module. So this module is responsible for uh, providing connectivity to the private application, and this one is responsible for internet security. So let's say you want to access private application. What will happen behind the scenes? When you try to open the application via a private IP address or via fully qualified domain name, behind the scenes, we will make sure, first of all, this user is authorized to access the application and has right security settings. So right now, I just open a LAN page of my Meraki MX. So why private IP address? So which does not have any authentication, by the way, but yeah, just for demonstration purpose. So with the help of the same client, your complete traffic will be proxied through our fabric for internet. When you access any website, we will make sure that you are accessing clean website, not malicious. And even we can also control the usage of different applications and services over internet. So for example, you want to make sure that your users are not leaking sensitive data over internet, like credit card details or banking details. Maybe you have turned on PCI compliance. So in that case, we will be sitting in the real time in the middle between user and the applications over internet. So in this example, a user is trying to upload credit card detail over a web-based form. So I just paste the credit card detail, and when I click submit in this web page, we are going to interfere and we are going to block it in a real time. We will never let that upload complete. We can also control or apply the similar behavior on different Gen AI applications, including ChatGPT. So right now, I'm communicating with ChatGPT. I try to paste the same credit card detail, and we will never upload or share that detail to ChatGPT. So we will restrict that. So I hope this session give you some good insights about Secure Connect architecture, how we can connect and how we can use. If you have any follow-up question, please feel free to ask once I turn it off. I'm also joined by some subject matter expert from Meraki MX team. Fadi is standing in the behind. So we both can answer any follow-up questions you may have. And please complete your surveys. Your surveys are very important to us. And don't forget to grab the Cisco Swag T-shirt before going home today. One last thing for continuous education, there are a lot of sessions still happening. Some of the slides I captured from one of the breakout session happen in Cisco Live US. So if you want to get complete slides for this session, please navigate to this breakout session from Cisco Live on demand. So please take screenshots if you want. Uh, so I want to give credit to these person who have created the content. So once again, thanks everyone for joining us today. I hope you guys find it informative. Yeah.